today. So we're going to finish 3-1. And then Zoomers, you'll get 3-2 on Monday, and then you guys got 3-2 ready to go. Everybody got that, right? Okay. All right. Hopefully this won't take very long. All right. A scatter plot displays the direction form and strength of the relationship between two quantitative variables. You need to know this. A linear relationship is strong if the points lie close to a straight line. And weak if they are widely scattered. Unfortunately, our eyes are not good judges of how strong a linear relationship is. To help us see the relationship better, we measure correlation. And again, I know it was a long time ago, but you did that in Math 1. The correlation measures the direction and strength of the linear relationship between two quantitative variables. I think that's one of your definitions as well you'll do next Wednesday. The correlation R is always a number between 1 and -1. For a positive association, R has to be greater than 0 because values greater than 0 are positive numbers. And for negative, it would have to be less than 0 because numbers less than 0 are negative. Values of R near 0 indicate a very weak relationship. As it gets closer to -1 and 1, it becomes stronger. All right, so yesterday you were asking, like, how do we know if it's strong or moderately strong or blah, blah. Everything happens. It'll come into this. So this is how you do correlation.
On the homework, what happened was like a complete curve. Would that be weak?
Yes.
Or would we still put moderate?
You can put weak because you know it's a super curve.
Okay, but if it's kind of a curve, then that would be.
Yes, because it's closer to that line.
Okay, gotcha.
Yep.
Jones, do I fill on these?
No.
Because I have residual squares, or these squares with reference.
Is that the ones I just gave you?
Yeah.
It's not those. It's the ones we worked on yesterday.
So I looked it up too and see that.
It's that one right there.
All right.
Oh, you got
That's
it?
the one you're
I
on.
must have skipped over it.
Sorry. No worries. Kendall, be on time. Jeez. All right, the extreme values, R equals 1 and R equals -1, occur only in the case of a perfect linear relationship. That means all of the scatter plot dots are on the line of best fit. And then it gives you some examples. So this does not look like any form at all. It's just a big blob of dots. Everybody understand that? Okay. So the correlation is 0. There is no correlation in this because there is no pattern. Now, if you look at these, they're compacted a little bit more and they kind of look like they're going down, right? Does everybody see that? It's hard. It's hard to see, but it's way better than this. You can actually see that it's in like a negative form. So it's a number close to 0 and it's negative because it looks like they're going down. Okay, because that's a weak. This one, You can tell that it's a positive correlation, but there's still a bunch of dots like everywhere. It's not a real good linear. So look at the difference between these two. Does everybody see this? This is a super strong linear because it's at negative 0.99. The negative just means that it's going down or it's decreasing.
Where are you getting the numbers from, like 9, 9?
They're there. They're already there. They're just giving you examples.
Oh, okay.
So I'll show you how to find them on your calculator. It's really simple.
Hi,
Okay.
can you help me put, got homework from last month? I forgot to put it in.
Yeah, I'll teach you. All right, and again, here is 0.9 because you can tell that it's linear and it compacts more. The more compact it is, the stronger it's going to be. So the less compacted it is, so we can tell that this is negative, but it's going to be a little weaker than that 9 because it's more scattered out. Okay, so those are just giving you examples. Oh, well, she should be on time. I am being nice. 10 minutes late. Okay. Our earlier scatter plot on the average points per game and number of wins for college football teams in the SEC is repeated below. For these data, R equals 0.936. I don't know if I still have these data in or not. Yes. So we had this data yesterday in for the points and the number of wins, right? All right. So what you can do, you guys remember doing linear regression? Our stat mode should be on
How do you turn the side on again?
mode and go to stat diagnostics. If that data is still in, you guys can do it or you can just watch. It's okay. So we're trying to find linear, so a linear regression. But the difference in us is that we're actually going to use number 8 because stats does A plus BX. Y'all, it's the same exact thing. It is the same exact thing. So don't stress out. The B is your slope. The A is your y-intercept, like always. We just use this form. And when I calculate it, because my stat mode's on, you see how I get that R? That's not 0.93. That's where that 0.93 comes from. So that's how you find it. So you do linear regression, and you find your equation. So our line of best fit would be negative 3.75 plus 0.44x. That's our line of best fit. Got it?
And how do you get that again?
Stat, calc, linear regression, the number 8, the second one. All right, this little word right here kills you guys. Interpret. You had to interpret percentiles on your test. You didn't do it. You had to interpret z-scores. You didn't do it, some of you. Okay, so how do we interpret R? I guarantee this is going to be on your next test. So that R tells us there is a strong or weak. Which one? Positive or negative? So strong, positive correlation. You can't stop there. Remember, what do you got to do? In context of the problem. Y'all don't do that either. I didn't count too much off for that stuff right now, but I'm telling you, it's going to start being major points off, okay? So be careful. All right, strong positive correlation between points per game. I just put PPG, points per game, and wins. You can't see the point that's circled. It's talking about this one. You can lightly see the circle, but it's real hard to see. Okay, but it's this one. So the point on the scatter plot is Mississippi that's circled. What effect does Mississippi have on the correlation? Justify your answer. Why? Okay, so correlation. Let's talk about it this way. With Mississippi. All right, let's think about it for a minute. We're going to look at our line of best fit. And I did listen to you, but see if you change your mind in a minute. You may not. It may be the same. with correlation, our line of best fit is kind of here with Mississippi. Everybody see that? If we take Mississippi out, this point right here is going to pull our line this way. Did that make it stronger or weaker?
Mississippi helps you get-
Good. Correlation with Mississippi is stronger. What? Oh, yep. Sorry. I was showing you Mississippi, which is closer to 1.
Would we need to do that in the future, or can you say stronger?
No, you have to justify everything because it says justify your answer. Okay? Without Mississippi, what would it do?
Oh,
The strength. So you're saying it would be weaker? And correlation would decrease. If you say one or the other, I would be fine. That's it. What was Mississippi 15, 16, 17, something too?
what's it, 16?
16.12. I think it's this one. So if I delete this out, my correlation went to 0.92. So it lessened it. So you guys could do that too. If you actually have the data, you can look at it that way. Okay. And you could say correlation with Mississippi is 0.936, whatever it said. And then correlation without Mississippi is 0.919.
What is the A and B for again? I'm confused about that.
Same thing it's always been for. Your A is your, right now, is your y-intercept. And then your B is your slope, or your rise over run increase rate of change. We'll talk more about the equation soon. I'm just showing you where everything's coming
We're
from.
not supposed to have that data that you haven't calculated, was it?
Yesterday we did it.
But if you put in stuff since then, from the home-
Right, from your homework, it would be there. All right, look at this one. Check your understanding. The scatter plots below show 4 sets of real data. A repeats the Manatee plot. B shows the number of tropical names, tropical storms, and the number predicted, sorry, I can't read today, before the start of hurricane season each year between 1984 and 2007. Plots, part C, plots the healing rate in micrometers per hour for the 2 front limbs of several newts in an experiment. And D shows stock market performance in consecutive years over a 56-year period. For each graph, estimate the correlation R, then interpret the value of R in the context. So what do you know this one is going to be? It has to be a what?
It's gonna be plus the one.
So it's going to be a positive number, and it's strong. So what can we give? It's-
We get like 0.9.
I think so too. I'm going to say 0.9. Because there's still a little scatter up here that's off.
How
It's-
close do we need to be with
It's just an estimate.
Go ahead and show us. 0.9 and 0.99 is a big difference from 0.9 to 0.5.
It's okay. We're just estimating right now. All right, interpret R in the context of the problem. So this one is boats registered in Florida and manatees killed. So what would this one be? I'm not going to write it down, but we're going to talk about them.
a strong positive, it's,
There is a strong positive correlation between
the number of boats owned and the number of men.
the boats registered in Florida and the number of manatees killed. Got it? So that is what you'd say on your test. So on the next one, what do you think about this one?
It's pretty weak.
0.6 something.
Is it increasing or decreasing?
It's positive.
Okay, so it is positive, so we're gonna have a positive number. But you said it was really weak because it's all kind of scattered out, right? So give me a good one.
I say like 0.5, 0.4.
I did 0.4. The book does 0.4.
If I've done 0.5, I'm
No, it's just an estimate. Interpret it in context of the problem.
The storm's predicted, there's a moderate,
Just do weak. Just do weak.
So like basically if it's
There's no
correlation.
correlation.
there is a positive weak correlation between storms predicted and the storms observed. Yep. All right, what about this one?
It's very weak.
So what is it gonna be?
0.1.
Yeah, 0.1, I like that one. So
Someone do. In the bottom.
it looks like it's increasing, so that's why I kept it positive. It doesn't look like it's decreasing. And the only reason I say that is because most of your points start here and then on the high end over here. So what's this one interpreted?
There's a positive weak correlation between the hearing rate and the
And on the other one, you can use a moderately weak. You can use moderately weak, that's fine, but they're not gonna kill you on that, I promise. Guys, girls. The next one,
negative. There's no correlation.
actually there is.
0.05.
Why do you think it's negative? You said negative.
This one and this one.
So we start here and we kind of finish over here. It looks like it's going a little bit negative, but it's really weak. It's hard to tell, right? So give me a good estimate. Negative.
Point
They're a little more clustered than this one is.
0.02.
I would do too.
So I really just choose one. No matter if it's negative or positive, you use the same things closer to one.
Yes.
Okay.
The sign only tells the direction.
Okay, gotcha. I'll do that.
All right, so this is the crappy part. How to calculate the correlation R. I already showed you on the calculator, but I'm gonna tell you how you do it by hand, but we're not gonna do it by hand because it's really, really crappy, okay? Has everybody got that? And as long as you can justify your answer, you're gonna be fine, all right? So we have data X and Y. Have an individual N, and remember N stands for the observation. So when we label this, your first data point, so your first observation, N1, we will label X1, Y1. Your second one, we would label observation 2 to be X2, Y2. So your third one would be X3, Y3. Your fourth one would be, X4, Y4, whatever. All right, so to find R, this is your formula. It's a really crappy one. One over N minus one, so the number of observations minus one. Big fat bracket. You will do your X observation, so your X1, minus your mean over your standard deviation of X, whatever your X is. So it was number of boats in Florida, right? But then you also have to do the number of manatees. So you'd have to do Y1 minus the mean of the manatees over the standard deviation of the manatees. Okay. Plus, then you do your second observation. And you do the same thing with it.
So we can grab it.
Yeah. And that's what I just told you. We are not doing this by hand. No way. And if there were 50 data points, you would do this 50 times. Right.
We're not going to
Do y'all listen to me at all when I talk?
Yeah, I'll listen.
How many times did I say we are not going to do it by hand, but I'm going to show you the formula? We're not doing it by hand. All right. So on your formula sheets that you have that I've put on Canvas now, this is the formula that you'll see. 1 over N minus 1. Epsilon, which means what? Summation. You're going to add them. Have you taken calc yet? Oh, wait, you are. That's why. Notice everybody that answered.
Does that kind of work as a bracket on this?
No.
Like it kind of says sum of everything past it.
It is, but it's not a bracket.
What about on this
It's
side?
just telling you to add it all up.
That's what I meant. I just-
It's all right. If you want to look at it as a bracket, you're fine. All right, y'all got that? All right. So I'm going to show you with this points per game and wins. I've already calculated R for you on the calculator, so you know how to do it on the calculator. I'll go over that one more time. But if we were doing this, everybody got that? Sorry, I moved it quick. Y'all good? Okay. So if we were doing this by hand, we would start with R equals 1 over, how many observations do we have?
Well,
12. So we would do n minus 1 or 12 minus 1.
Where do you go from?
There are 12 states. You good?
Yeah.
Okay. And then you would have to start with Alabama. So I'm going to write that little ALA up there. You would start with your X value. So Alabama's right here. Your X is 34.8. You would subtract your mean, and up here it says the mean X is 27.07. Over whatever your standard deviation is, 7.16. And you would keep doing that, and keep doing that, and keep doing it. But we're not going to. So remember, in our calculator, how do we do it? So we're going to go into stat. We will edit L1 and L2. My pen is about to die. Once we edit L1, 2, we go back into stat, calc, and Lin reg, but we want to do A plus BX, and that's number 8. Keep hitting enter, and you'll get your R is 0.936. And you could do that with any data set that you have in there. How you want, I mean,
I was talking about homework, how'd you get the scatter plot again? Gotcha, I'll come to this sheet.
so second Y equals, turn your plot on, make it a scatter plot, zoom, none. All right, everybody good now? No, sorry. You're okay. I thought you were telling me to like move it, like move my paper so you could see the stuff up there. Everybody good? All right. What does correlation measure? So this, if you guys look, it says points per game, and it's got 15, 20, 25, 30 on your scales. Here it has wins. What does this one have? What's different?
It's something that you see.
It's got the Z's. So what did they do to it if it's got the Z's? Standardized it. How do you know it's standardized? The mean is at 0 and your standard deviation is 1. Okay. All right. So let's look. Just this first one. The vertical line is your mean. It's your mean points per game. If you need to write points per game, write that. So that makes the horizontal line the mean of Y, which is the mean wins. And then tell me about this graph. Okay. You are correct. I'm not gonna write it down yet because we're just gonna talk for a minute. Let people write. What else do you notice? Just talk about it. Like, don't overthink this because I'm not trying to talk technical stat terms with you. Talk to me about this graph. What do you
There's
see?
no outliers.
Possibly not. What else do you see?
Have a strong positive correlation.
She said that. You're right. What else? What do those two lines do? What do they do to the graph?
The very center.
They kind of do give it quadrants. So what do you notice?
Most all of the dollars in the first and third.
Right. So that's what I wanted you to get at. Most points are upper right or lower left. Seeing them in those quadrants, and I use quadrants lightly because they're not really quite, you know what I mean. All right. Confirms the positive correlation, which is exactly what the both of you said. So what that means is above average points produces above average wins. Above average points produce above average wins. Okay, so let me explain that one more time. Let me get everybody to write it down, then we'll go back to the figure. It's just a lot of writing from here on out, not a lot of examples. All right. When we look at this, remember these are averages. So if it's above average here and above average here, so this is above average on both. This one would be above X, but below Y average. Does everybody understand how that's working? So here's your X. These spots, if you had points up here, they would be above the X. You got that? But here's the Y coordinate. These are lower than the Y mean. So they would be below Y. Make sense? Okay.
So this one would be below that.
What's this one?
Below the.
Below both. It's below the horizontal and to the left of the vertical. So it's below X and below Y. What about these? Below which one? Look at it again. They're below X. This quadrant right here is, oh, you can't see it. Sorry, y'all. Is below X, but above the Y. So it's to the right of Y. Okay. All right. So look at your standardized.
So if it was to the right of Y, then that means above Y.
Yes.
Okay, gotcha.
Okay. What did we do on this? Uh-huh. So we transformed X and Y. By subtracting the mean and dividing standard deviation. What's your formula for z-score? The observation minus the mean, subtract the mean, divided by the standard deviation, divide the standard deviation. That's all it's saying is the formula. Why do we do that? Converts, perfect. X bar to 0 and your standard deviation to 1. Remember that we're multiplying them in that big long formula that we didn't do, right? So we're multiplying them and then we're adding them to the next value, okay? All products of z-scores will be positive, no matter what. And then if it's negative, just to reiterate, the points will be in the upper left. So if it's negative, remember it's going to look like this. So upper left and lower right. Is where your values will be. All right, I'm gonna go ahead and go out and come back in. These last 2 pages will not take long. It's just writing. It's no real examples or anything. Okay, so stop share. I'm gonna stop recording.